All right, so we really only have 5 more problems to do. So I'm going to come back to number 18 just because the other ones are similar and 18 is not. But, all right, so this says find the average rate of change of the function over the given interval. So anytime you see average, that implies algebra. And so I'm given a function of 6t squared minus 1. So f of t is 6t squared minus 1. And my interval is from 1 to 1.1. So those are t values. I'm starting with t equals 1 over to t equals 1.1. So average value simply means, hang on, this is too small. All right, average value simply means find the slope. Find the average rate of change. So if I evaluate this at 1, because remember for slope, I need 2 points. And so right now I got 2 x values, but I don't have their corresponding y values. So anytime you need a y value, go back to your original equation. So if I evaluate this at 1, 6 times 1 minus 1 is going to be 5. Okay, so the 0.15 is on this function. And then the point 1.1, comma, well, 6 times, I'm not even going to try this stuff in my head. You should know that by now. All right, so I've got 6 times, get out, 6 times 1.1 squared is 7.26, and then minus 1 is going to be 6.26. And so that is this point. That's the 5. So, all right, so 6, okay? So I've got 2 points. So 6.26 minus 5, because this is y2 minus y1, will give me 1.26 over 1.1 minus 1 is going to be 0.1, and then I get 12.6 for an answer, okay, once you divide that. So that's your average rate of change. So what does this mean? This means I've got a parabola that has been stretched by a factor of 6, and I've dropped it 1 unit. So it looks like this, and it's pretty tall and skinny, okay? And between a value of 1 and 1.1, the average rate of change, so this is a secant line. Remember, a secant line shares 2 points. So the slope of that secant line is going to be 12.6. So it's pretty steep. All right, so now what does this next part say? So I've got a 12.6 here. Now compare this average rate of change with the instantaneous rates of change at the endpoints of the interval. So instantaneous implies calculus. So I'm going to take a derivative. So f prime of t is going to be 12t, okay? And now I can find the instantaneous rates of change at the endpoints of the interval. So at a value of t equals 1, so f prime of t, oops, sorry, I meant that to be 1. F prime of 1 equals 12 times 1, which equals 12, okay? So that should be common sense because 12 times 1. And then take your derivative and evaluate it at 1.1. So 12 times 1.1 is going to be, bang, all right, 13.2. So this is 13.2 because it's 12 times 1.1. Now, here's the magic of this. What's the halfway point between 12 and 13.2? It is 12.6. All right, which that doesn't work every time. So don't get all excited and think you just, rewrote calculus because you didn't. All right, so that's 12 and that's 13.2. Okay? So what else do we have? We have a silver dollar is dropped from the top of a building that is 1,386 feet tall. Use the position function below for free-falling objects. All right, so I need to clarify something first. When we give you a function, the given function is your position function. Okay? It tells you where things are. So you can plug in an x value and it will tell you the height, which is your y value. Your first derivative is going to be your velocity function. Okay? Your second derivative is going to be acceleration. Okay? Acceleration. I feel like that's spelled wrong. All right. So for, original function is position. So if you ever need to know the position of something, go back to your original function. First derivative is velocity. Second derivative is acceleration. All right. So what does this mean? What I have is a silver dollar is dropped from the top of a building that is 1386. So determine the position function. And what I'm told here is that my initial velocity must be 0. I know that because it was dropped. It wasn't thrown. It wasn't shot. It wasn't anything like that. All somebody did was just let go and let gravity take over. So V sub O, so I'm saying V sub O. Okay, V sub O is your initial velocity. Well, my initial velocity in this case is 0. And then what is my initial position? So S sub O is where did this thing start? Well, it started at the top of the building. That's 1386. So my position function is negative 16t squared plus 0t, because my initial velocity is 0, plus 1386, because that's the top of the building. All right, so at t equals 0, where is your silver dollar? It's at 1,386 feet tall. Okay, so that should make sense. All right, your velocity. So if I've got a position function, or the starting point, okay, the derivative of that will give you the velocity function. And then the second derivative of the position function, which is the first derivative of velocity, will give you acceleration. Okay? What does that mean? I need to know what my first derivative is. So take a derivative, and that gives me a negative 32t. And if you have had physics at all, you should recognize that as gravity in feet per second. Okay? Or feet per whatever. All right, so determine the average velocity on the interval from 2 to 3. So I want average velocity, and I want it on the, so that tells me algebra. Okay, so don't do any calculus. So I'm going to take my position function, and I'm going to evaluate it at 2, and I'm going to evaluate it at 3, and I'm going to find the average velocity. So if I shove in at 2, I get negative 16 times 4, and then I'm going to add 1386, and that gives me 1322. So if I shove in a 2, I get a 1322. So after 2 seconds, the silver dollar is at a height of 1322, and that should make sense because it's falling. All right, at 3 seconds, what is this thing at a height of? So I've got negative 16 times 9 plus 1386, and I get 1242. Okay, and so what is my average velocity? So I just need to put this into the slope formula. So 1242 minus 1340 or 1322 should be negative 80. Yeah, I'm right. All right, divided by 1, because that's x2 minus x1, gives me a negative 80 feet per second. Okay, so on average, this thing is falling at 80 feet per second. It's falling, that's why it's negative. If it was going up, it would be positive. So find your instantaneous. What does instantaneous tell you to do? That tells you to take a derivative. So I'm going to use this formula and find it at exactly the moment that t is 2 and exactly the moment that t is 3. So negative 32 times 2 is going to be a negative 64. Okay, and negative 32 times 3 is going to be a negative 96. Okay, so find the time required, and that should also make sense. 2 seconds into this thing, it's falling at a rate of 64 feet per second. After another second passes, it's going faster. Okay, so it's at negative 96 feet per second. Find the time required for the coin to reach the ground. So where do I go for that? That's a position. I want to know when this thing's position will be 0, because it started at an elevation of 1386. So I'm going to take negative 16 t squared plus 1386. When will u be 0? Okay, so I'm going to subtract 1386, and then I'm going to divide by negative 16. So negative 16 is, I get 86,625. So subtracted and then divided by negative 16. And now I'm going to take a square root. So remember, any time during the process of solving a problem that you have to take a square root, you need to take a positive and negative, but time can only be positive, and so don't take a negative root. All right, so raise that to the 0.5 power, and I get 9.31. So 3 decimal places. So 9307. Okay. Find the velocity of the coin upon impact. So this is velocity. And then what's it in terms of? It's in terms of time. So on impact, it's been traveling for 9.307 seconds. So I need to multiply that time by my velocity function to find out how fast it's going. So times a negative 32 gives me a negative 297,832. Negative 297,832. And so it's falling at a rate of almost 300 feet per second. Okay. So that being said, you can do this one. This one is in meters per second. Okay. So I'm going to let you fill that one in. This one is going to be the volume of a cube with sides of length s are given by v equals s cubed. Hence the cube. Okay. Find the rate of change of volume. So I'm trying to find how volume changes. So take a derivative with respect to s when s is exactly 9. Okay, so if I take a derivative, that means my derivative, or how is the volume changing, at 3s squared. Well, when s is 9, I got 3 times 81 is going to be 243. So the volume is changing at 243 centimeters squared per second. All right, so now this last one, and I'm hoping we have time. All right, so here we go. I've got a function of, all right, hang on, I'm going to pause this so I can just keep this in a single video. Hang on, pause. All right, so going back to number 8, I already set it up and wrote it for you. I've got some multiple of a square root of x, which is this curve, and I've got a line of y equals 4x plus 36, and I want this line to hit this curve. So I got to find out how tall to make the curve in order for this to work. So I'm going to set the functions equal to each other. So k times the square root of x equals 4x plus 36. And then I'm going to set their derivatives equal to each other. So for right now, I'm going to pretend that k is a number. And so that means I actually have k x to the 1/2 equals 4x plus 36. Okay. And all I did was rewrite. I haven't done calculus yet, but this is a number that's coming along for the ride. So 1/2 times k, x to the negative 1/2 needs to equal 4. Okay, so I'm going to solve this thing for k. So multiply both sides by 2. So I've got k over the square root of x equals 8. And then I'm going to multiply both sides by the square root of x. So I get k equals 8 root x. And now I can take that information and plop it on back in here, and I can solve for x. So k is 8 root x. So 8 root x times the square root of x is 4x plus 36. Okay. The root of x times the root of x is x. So I get 8x equals 4x plus 36. Subtract. So 4x equals 36. So x must be 9. Okay, so you know that x is 9. Well, I need to know what k is. Okay, so if this is the square root of 9, come over here. So k times the square root of 9 equals 4 times 9 plus 36. So I get 3k equals 72. So k must be 36. Okay, so that's the value that you need. Holy cow, that was fast. All right, so hopefully that made sense, and hopefully I didn't make a mistake because I just ripped through that. Anyway, so that's this section. And so you are now ready for the rest, or you're ready for the next section.